bending water example, we see a stream of water bend towards a PVC pipe that has been negatively charged through triboelectric charging. If we could zoom in to see the molecules, we would see water molecules falling in a random assortment with their ends facing different directions. Water molecules are polar molecules, and the oxygen side of the molecule is slightly more negative than the hydrogen side of the molecule, which is slightly more positive. When we bring this negatively charged rod near the molecules, the negative ends of the molecules repel from the rod and align so that they are furthest away from the rod. This also points the positive end of the molecules towards the rod, and since opposites attract, the water molecules are pulled towards the negatively charged rod, bending the stream. At the meter stick helicopter station, we saw that you could move a meter stick by placing a charged rod near it. The meter stick is a neutral object, with charge evenly distributed throughout, and it is wood, which is an insulator, so the electrons cannot move through the material very easily. When the negatively charged rod is brought near the stick, the electrons of the atoms at the surface are shifted in a way that those atoms become polarized, which leaves the surface of the stick with a more positive charge. Remember, we have not charged the meter stick, as the amount of charges in the stick have not changed, but we have moved the charges so that the edge of the meter stick is more positive. Since opposites attract, the negatively charged rod attracts the positive surface of the meter stick, causing it to move. At the Slow Your Roll station, we were able to roll an aluminum can towards a negatively charged rod. This is similar to the meter stick helicopter station, except this time we are using a conducting material, metal, instead of the insulating material, wood. With conductors, electrons can jump between atoms and move through the material. Charges don't simply shift within atoms. They can move through the whole object, and in our case, this is the can. Because of this, the side of the can nearest the charging rod is now positive, and the side of the can furthest from the rod is negative. The negatively charged rod repels the negative charges in the can, forcing them to the other side of the can. We have polarized this whole object. Since opposites attract, the positive side of the can is pulled towards the charging rod, causing it to roll. For the Wallcrawler Station, we gave a balloon a negative charge by rubbing it on rabbit fur. In the simulation, a wool sweater is used, which achieves the same effect. The balloon now has a negative charge, and when we bring it near the neutral whiteboard, we can see that we are polarizing the whiteboard by repelling the negative charges with the balloon. When the balloon is put against the whiteboard, opposite charges attract, causing the negatively charged balloon to adhere to the positively charged surface of the whiteboard. In our actual demo, we saw the balloon fall while sticking to the whiteboard. This is because of gravity, which the simulation is not factoring in.